Inverse variation. In question 1, we just have to set up an inverse variation equation for what is given. Same in number 2. So when we read number 1, Boyle's law states that when a sample of gas is kept at a constant temperature, the volume varies inversely with the pressure exerted on it. Write an equation for Boyle's law that expresses the variation in volume as a function of pressure. We know that when we talk about inverse variation, we're talking about y equals constant over x. Here we're going in to substitute in v for our y, p for our x, and we're left with v equals k divided by p. For number 2, astronomers can use the brightness of two light sources such as stars to compare the distances from the light sources. The intensity or brightness of the light is inversely proportional to the square of the distance from the light source d. Again, we're using the same function, and we're going to substitute in the I for light and the d for the distance from the light source. So we end up with I equals k divided by d. On number 3, we have if y varies inversely as x and y equals 2 when x is 25, find x when y equals 40. So we start off with, we have to find the product. So we have y is 2, we have x is 25, so that means my constant is going to be 50. When y equals 40, so we know that x will equal our constant over our y, so we end up with 5/4 or 1.25. For number 4, if y is inversely proportional to x and y equals 4 when x equals 12, find y when x equals 5. So again, we're going to find the same thing that we did in number 3. We're going to repeat the process. We have y equals 4, x equals 12, so that'll give us our constant. So our constant is going to be 48. And now we need to find y when x is 5. So we'll start with y equals 48 over x, which is 5, or 9.6. For number 5, the illumination product of a light source varies inversely as the square of the distance from the source. The illumination produced 5 feet from the light source is an 80-foot candles. Find the illumination produced 8 feet from the same source.